Sriram, lecturer at Kevin College. So today I am dealing the topic authentication in hash functions. This is chapter 11. So in this chapter we will deal mainly about authentication algorithms and so what is an authentication. So message authentication in the sense we can provide authenticity or identification to any person. This is called the message authentication. So in the sense you should give a student that there is no modification happen to any message, to the encrypted message. So giving a student that there is no modification to your encrypted message, and also it is protecting the integrity of the message. Integrity in the sense the reliability of the message. So by providing Mac, we can provide the reliability of the message. And you can also validate the identity of the originator. So you can also know from whom you get the message. The originator in the sense the person who sent the message. So usually in symmetric encryption, simple symmetric encryption doesn't give information that from whom you get the information. Okay. So but by using the Mac, we can clearly say the person who is the originator who sends a message. So this sort of identification you get. And the same way you can also provide non-repudiation of origin. So non-repudiation of origin in the sense the sender cannot claim that he didn't send the message. So there should be some conflict between the sender and the receiver or between any two participants. And in the conflict the sender might say he didn't send the message, even he sent the message. But if it is a simple symmetric encryption, the conflict resolution people cannot give decision because that can be encrypted either by the sender or receiver. But if you use this Mac, you can clearly give decision who provided this message, who created this message, who encrypted this message. So this is a non-repudiation of origin. In the same way, you should also need to consider the security requirements before providing authentication. So for providing a message authentication, we are having three alternatives. We can use any of these three techniques. Okay, the first one is a simple message encryption. Message encryption, which we have followed till now. And the other thing is MAC, message authentication code. So you use a message authentication code. And another technique is hash function. So these are the three different types of techniques for providing the authentication. Now let us see some security requirements. So the first one is the disclosure. So you should provide your message not to be disclosed. It has to be kept secret. So that is called the disclosure. You have to make your message confidential. Traffic analysis. So we discussed this in the second chapter. So analyzing what the attackers will do, they not only attack the messages, they not only see the contents of tries to see the contents, they also tries to observe how the messages are flowing in a network, how the messages are passing through the network. So they will just see the traffic flow, how the packets, data packets are transferred from which user to which user. So by gaining that information, they can. It is one of the advantages to the attacker for gaining knowledge. So do the traffic analysis, and next masquerading. It is just like pretending like a legit. So the masquerading is pretending like a different user. So the attacker will pretend like a legitimate user and hacks the messages, sends complicated messages. And next, content modification. It is just modifying your contents. the message contains is the content modification. Sequence modification. Sequence modification is the changing the sequence of messages. So what the attacker will do is he changes the sequence of the messages and sends it to the receiver. For example, if you see our college is conducting the public examinations, so we have to receive question papers from university. So the university will send the question papers according to the timetable of the examinations. So if any attacker hacks those question papers in the middle and stop with those question papers for one day. For example, today we have to conduct the maths arithmetic examination. So in the middle, any person who stops the question paper and sends those question paper tomorrow and sends a different question paper today, like social, so we are in a problem. So such type of sequence modification will create a problematic to any participant. So that is sequence modification. And next, timing modification. It is just like changing the type. For example, if any message or packet has to be received at a particular time, so time is set like that. So if in the middle, if any person changes the time, so that will be received in a different time. So usually in cryptography, for every message they append one timestamp, that is called timestamp. So this timestamp will reflect the presentness of the packet. So for example, if the timestamp it is written 2014, so this message is of last year's. So in the timestamp if it is written 2015, this is the present year's message. So if we have to accept only the present year's message or the previous messages, so if any attacker changes the time, which is 2014 to 2015, and sends it to us, we accept this because this is 2015. Such a timing modification can be done by the attacker. And source repudiation and destination repudiation. So source repudiation in the sense the person who sent the message might claim that he didn't send the message, and in the same way the destination repudiation, the person who received the message might claim that he didn't receive. These are the source repudiation and the destination repudiation. These are the things which we have to come across, and we have to provide a solution to these problems. The next concept is the message encryption, which is one of the type of the authentication. So message encryption is just provides a measure of authentication. If you see message encryption in private key encryption, so the encryption itself provides authentication. In the sense, you see the private key encryption, sender and receiver both use the same key. So if receiver receives any message, he confirms that message is from the respected sender only, because this key is known only to that person. So the authentication is implicit in that case, in the private encryption. So if you use symmetric encryption, sender knows, receiver knows sender must have created. Receiver confirms that this message is created by sender only, because only the sender knows that key. And content cannot be altered. So known content cannot have been altered, because the content which is the message cannot be altered, because no other person knows the key, then no one can alter that message. But but only thing we have to do is we have to see the redundancy or checksum. So how can you find out any modification happened is you can calculate the checksum values, any redundance values like this to detect any changes. So if any attacker might put the same values which is in the text, then it is a redundancy. So we can check the checksum for finding out any changes happen to our message. If the message encryption is in public key encryption, so the sender or the receiver might have no confidence who is the sender, because here in public key encryption, the encryption is done using the public key of the receiver, because the public key of receiver knows by many participants, many users, anyone can encrypt that message. So the receiver has no confidence of who is the sender. Okay, because this public key is known by many one. But you can come across, so you can overcome this problem in the public key encryption itself by using the signatures. If sender signs a message using his private key, then we can clearly say that this message is from this particular sender. Because sender is signing and no other person can sign with his private key, because this private key is known only to his sender. Okay. So the sender will encrypt with his private key. This provides the authentication, and then he encrypts a message, the same message, with the recipient's public key. So then we can provide both the authentication and also the confidentiality. So we can provide both the authentication and confidentiality by encrypting the message first with his private key and then encrypting the same message with the receiver's public key. And so here also he has to recognize the corrupted message. So any corruption has happened in the message, he has to find out. Now let us see the second technique, message authentication code, MAC. So it is generally an algorithm. MAC, message authentication code, is an algorithm which creates a fixed size block. For example, it could be 64-bit block or 128-bit block, whatever the block it might be. It is a fixed size block. So by calculating a checksum on the original plain text, you will get this block. So you have to use the key for calculating the checksum. So just like symmetric key, you use a secret key. The same way you have to use one key for calculating the checksum. So this MAC is a symmetric key. So the MAC depends on the symmetric key encryption. So it is not the public key encryption, it is a symmetric. But the key is not reversible. So it doesn't need to reverse a key. In the sense, in symmetric key encryption, if a sender encrypts a message using a key, the receiver decrypts a message with the same key by following a reverse procedure. So here decryption is the inverse of the encryption. But whereas in MAC, the decryption is not the inverse. The receiver doesn't do any decryption procedure. He does the same procedure what the sender do. He calculates the same MAC on the message, plain text. So just the sender do. How the sender do? He calculates the same message and then he checks whether he gets the same message what the sender gets. So that is how the MAC is calculated. Receiver performs same computation and matches the MAC. So and the receiver gets the assurance that the message is unaltered and comes from sender. So by doing so, the receiver can confirm that there is no modification. So if he calculates, the receiver calculates the same MAC which the sender calculates. So and the receiver confirm if there is any modification happened in the message, that reflects in that block. So what we have to observe is, if any modification happen to your plain text, that reflects to your exercise block called Mac. So by looking at the change, you can clearly observe that some modification happened to your content. That is the technique followed in the Mac. So now let us see the diagram of the Mac. So this you can understand. So this is the source and this is the destination. So the version of plain text. So for this version of plain text, the Mac is calculated using the key, that is K. So here checksum is calculated, and this checksum is appended to your message, to your original message, and sends to the receiver. So the receiver gets the original message and also the checksum calculated. This checksum is a Mac. So here it is written C of K comma M, that is checksum is calculated using the key on the message M. So now what the receiver do is he takes this value. So this is the checksum value, and he calculates the same checksum on the plain text, just like the sender calculates. He calculates by using the same key and he gets the value. So if both these values are same, he compares both these values. If both these values are same, he confirms that there is no modification. So if any modification happened with the generated calculated Mac and received Mac, he gets assurance that there is some modification happened. But here there is no confidentiality is provided. Message is not encrypted, so message can be, there is every chance that message can be hacked by any person. Here with this diagram you can only say that, well, you can only check whether any modification happened or not, but we are not protected. So you can also do combination of both, that you will see better. Now let us see about message authentication code. Okay, so we clearly know that Mac provides authentication. So we can also provide secrecy. So how you can provide secrecy is you have to use two keys. One key is for calculating the Mac and one key is for encrypting your message. Okay, you can compute Mac either before or after encryption. One thing you have to notice is you can calculate Mac after encryption or before encryption. If you calculate after encryption, so your Mac is on the ciphertext. Okay, if you calculate before Mac, if you calculate the Mac before encryption, your Mac will be on the plain text and your Mac is also masked. It is because you are encrypting both the message and the Mac. So your Mac is also masked. If you calculate the Mac after encryption, your Mac is not masked because it is done after encryption. But the good practice is always calculate Mac before encryption. Now, why you have to use the Mac? Sometimes authentication is only needed. That is, for some application there is no need of confidentiality. So those applications require only the authenticity. So whether modification happened or not. Usually in e-commerce applications, you need your requirement is more authentication than the secrecy. So in those cases, this concept is very helpful. And also in archive use for storing huge databases also, you need authentication. One thing is, this Mac is not a digital signature. Mac is just calculating a value for checking whether any modification happened to your message. But digital signature is identifying a user. So that is the difference. Now let us see the properties of Mac. A Mac is a cryptographic checksum. As I already told you, Mac is a cryptographic checksum. Mac is C is a checksum. Checksum calculated on the message using the key K. what it does is it condenses a variable length message. So the message can be of any length. It reduces that message to a fixed size block by using the secret key here. So that fixed size block is called an authenticator. So a fixed size block, because you are authenticating that message, the whole message by looking at simple fixed size block. So that is called authenticator. And this block is a many to one, and this MAC many to one in the sense you can use the same MAC for many messages. It is not some like for this particular message this is MAC. It is not like you can calculate the same MAC on different messages. For different messages you will get different value. That is only the difference. So you can also say it is a many to one function. Now let us see the requirements for MAC. What are the things which are required for providing MAC? So by considering many different types of attacks, you can think some requirements to satisfy the MAC. So they are knowing a message and MAC is infeasible to find another message with the same MAC. You know a MAC value and also a message. So by knowing these two values, a message and a MAC, you cannot find out another message for which you calculated the same MAC. So you use the same MAC on another message, but you are still not able to find out that another message. So that type of complexity is needed for a MAC. And MAC should be uniformly distributed. This is the technique followed in the MAC. So it is like you are having a 26 letters. Totally you are having 26 letters in an English alphabet. So those alphabets you spread them. You write different letters in the text. So what the MAC is saying that you have to use each letter uniformly. If not, at least similar to it means you have to use all the letters uniform. That is, if you use letter E for 1000 times and letter K for 10 times, there is a large difference. So that shouldn't happen. So all the letters has to be uniformly used. So this is just an example. So you have to uniformly use all the resources. So that is the technique followed in the MAC. That has to be done. The MAC has to be properly designed, properly evaluated. You have to use the uniform distribution, and the value of the MAC also depends on each and every bit of a plain text. So the value which is calculated for a MAC, it depends on each. So that means that if you change even a single bit or single alphabet in a plain text, so that reflects to your MAC code. So the value of the MAC code will be changes. That is how you can easily find out even a single change happened to your message. You can easily find out. So that is the technique. So this is all about the MAC. And the next technique is the hash functions. So hash function is also similar to MAC. So hash functions will also do the same, perform the same thing what the MAC do. So but the approach you followed is different. So here in the MAC hash function also, you will calculate a hash code which is a fixed size block, and any change, and this fixed size block is a representation of a variable length message of any length. So but the difference is the MAC you use the private key encryption. Key, whereas in hash code you use public key encryption. That is the main difference. Okay. And hash is also used to detect changes to messages. So it is also used to detect whether any changes happen to your message. So there are various ways to do hash function to your message. So it is often used to create digital signatures. So the hash functions are often used to create digital signatures. So you can create, instead of simply creating a simple digital signature, if you calculate hash code and do digital signature, that will be a better way of providing digital signature. So let us see the diagram of the hash. You can clearly understand how the Mac hash function is calculated. So initially the message, the plain text, we calculated a hash value. So this is a function. It doesn't use any key for generating this function. So you calculate a hash value, and that hash value is encrypted using the private key of A. So that is a digital signature. You are encrypting with the private key of this sender. So no other can modify this message because it is encrypted with the private key. So that is why. So this is called a digital signature. So you encrypt the hash, and this encrypted hash is appended to the plain text, and that message is sent to the transferred to the receiver. So here the receiver, what the receiver received is, he receives the plain text and also the appended hash value, appended hash code, which is encrypted with the private key of A. Okay, this can be decrypted by anyone. So what the receiver do is, he calculates the hash value just like the sender calculates the hash value. He also calculates the hash value, and he decrypts the value, decrypts the hash code which he received. So he can decrypt this value by using the public key of A. So he compares whether the calculated hash value is same as the decrypted hash value. If both are same, then he confirms that there is no modification in the middle, and also he confirms this message is from a user A. So both the digital signature and the content modification verification is done by using the hash function. Now let us see, the simple hash function is just doing exclusive of many message blocks. If you exclusive of many blocks, it is just simple doing exclusive of many blocks. So but by doing this procedure, it is not securely manipulated message. That is, it can change the hash or it might not change your hash. So that's why it is not very much sufficient for providing a hash. So you can see in the next chapter how to create a strong cryptographic functions. So in this chapter we discussed only how to, so what is the procedure of a function, how the hash value is calculated. Okay. Now birthday attacks. Next course of birthday attack. It is just like an attack on the public key encryption. So it is a 64-bit hash. You can think that 64-bit hash is secure, but that is not. That is attacked by a birthday paradox. So what the opponent do is, he generates a 2 power m by 2 variations of valid messages. So he calculates 2 power m by 2 variations of valid messages. So all with essentially the same meaning. So all of them are having the same meaning. And also he can generate 2 power m by 2 variations of bizarre and fraudulent messages. So by calculating these both two, he compares with a probability greater than 0.5. So this is the birthday paradox attack. So here what this algorithm will do is, attack will do. So it checks a signature of valid message and then substitutes a forgery for a valid signature. So it will just see the signature of valid message and tries to substitute the forgery. So in this way, the hash code can also be attacked using the birthday attacks. But the thing is, if you can use larger Mac or hash values, you can protect. Let's go to the summary. So In this chapter, we discussed about the message authentications, what is a message authentication, and the different types of authentications. We are having three types: message and simple message encryption, where it is in a private key or a public key, and calculated max, and then finally hash functions. So this is all about the MAC codes and the hash functions. Thanks for watching this video.